Imagine being hit by a heavyweight boxer's punch, but concentrated into a single point on your chest. That's roughly what it feels like to stop a bullet with a bulletproof vest. Most people think a bulletproof vest is an impenetrable shield, a super strong material that simply blocks the bullet. In reality, the vest's job isn't to be tough, it's to spread out energy. A bullet carries an enormous amount of kinetic energy, determined by its speed and mass. When it hits a vest, that energy has to go somewhere, and the vest's design determines exactly where. Modern vests are built from layers of aramid fibers, like Kevlar. These synthetic fibers are incredibly strong, but their real secret is how they interact with a projectile. When a bullet strikes the outer layer, it doesn't just bounce off. Instead, it strikes the fibers, which stretch and deform around the bullet like a net catching a fastball. The fibers absorb the impact by stretching, which converts the bullet's kinetic energy into mechanical deformation and heat. This process spreads the bullet's energy over a larger area and over a longer time. The vest is made of dozens of layers, each one contributing to this energy dissipation. Each layer catches the bullet a little more, slowing it down progressively. This is why bulletproof vests are flexible, not rigid. The layers need to move and deform independently to do their job effectively. The process of stopping a bullet is incredibly fast, in milliseconds, sometimes less. The entire event happens before your nervous system can even register pain. But here's the catch: even though the bullet doesn't penetrate, the energy has to be absorbed by the body. That's why a vest stops the bullet but doesn't stop the blunt force trauma. The wearer is essentially struck by what feels like a sledgehammer. The force is powerful enough to break ribs, cause internal bruising, and even damage organs. That's why bulletproof is a misnomer. Technically, these vests are bullet-resistant. They reduce the risk of penetration, but they don't make you invincible. The level of protection also depends on the type of bullet. A vest that stops a handgun round might not stop a rifle round, which has much higher velocity and energy. Rifle rounds travel at over twice the speed of a handgun bullet, delivering kinetic energy that can overwhelm even the best aramid vests. To stop rifle rounds, vests often add hard plates, made of ceramic or steel, that shatter or deform the bullet on impact. These plates spread the bullet's energy over an even larger area, but they also make the vest heavier and bulkier, which is a trade-off for protection. The same physics applies to other protective gear, like bomb disposal suits. They protect from shrapnel and blasts by layering materials to absorb and dissipate energy. Even police officers and soldiers who wear vests regularly still experience pain and injuries from gunfire, highlighting the limits of body armor. The design of vests has evolved over decades, from heavy metal plates to lightweight flexible fibers, but the core principle remains the same: energy management. Researchers are now exploring liquid armor and other advanced materials that could dissipate energy even more effectively, potentially reducing blunt force trauma. These innovations aim to create vests that not only stop bullets, but also reduce the impact on the body, making them safer for the wearer. So next time you see a bulletproof vest, remember, it's not a magic shield. It's a sophisticated system of energy dissipation designed to save your life, but not to spare you the punch. Subscribe for more stories like this.